Hi everyone, welcome back. Today's lesson is going to be on finding angles on right triangles. So before, what we were doing was finding the missing side of a right angle triangle, knowing one of the other sides and knowing an angle. So now we're going to know what the two sides are, and we're going to try to find one of the angles. Okay, so in this lesson we are given two side lengths and are finding the missing angle. So when we're trying to find the angle, we're going to use the inverse functions of all the trig functions. So the sine, cosine, tan, there's going to be an inverse button for each. So for example, if I'm trying sine theta, so theta is just the sign we use to symbolize an angle. So it will sit in one of the corners of a triangle, and it's honestly just a symbol. So sine theta equals 0.8. We need to bring this sine to the other side. So when I bring the sine to the other side so that theta is by itself here, I need to have the sine inverse function, so this one here. So I'll get sine inverse of 0.8. This is what I'm going to plug into the calculator. So the Desmos calculator is a great one. Under function, we've got the sine inverse, and then I type in 0.8. That gives me 53.13, which is the answer right there. So then example for cosine, I've got cosine theta equals 0.6. I put the cosine on the other side as an inverse, and then I type in, under function, I've got cosine inverse 0.6. It also gives me 53.13. And then a tan example, so I have tan theta. So right now I have 4/5, so it's going to be a fraction. So how do we enter that? Well, first we need to do tan theta, tan inverse is going to be 4/5. This is another way you can represent fractions, so 4/5. So we're going to put that into the calculator. So function tan inverse, and then I've got 4, and then we can do the a/b, 5. This gives me 38.66. I'm going to round the 5 to a 6 because of the 9. So we get 38.66. So you only have to use the inverse if you're finding an angle. So if you aren't finding an angle and you're actually finding a side length, so let's say we want to find the hypotenuse, then we won't use the inverse function. So example 1, for each of the following triangles, calculate theta to the nearest degree. So there's my theta symbol here. So we're going to try to find this angle. I'm going to label all the sides. So that's my opposite, that's my adjacent, that's my hypotenuse. I have my adjacent and I have my hypotenuse. So this means we're going to use CA. Cosine equals adjacent over hypotenuse. So my cosine theta equals adjacent is 8/15. We're going to bring that cosine to the other side, so it's cosine inverse, and I have my bracket 8/15. We can plug that into the calculator. So cosine inverse 8/15. This gives me 57.769. We want to round this to the nearest degree, so we don't want any decimals. So we're going to round that 7 up to an 8. So my answer here would be 58 degrees. Example 2. So here's my theta symbol here. So let's label the sides. That's my opposite. That's my adjacent. And then the hypotenuse. Remember, the hypotenuse is always the side that's opposite of the right angle. So for here, I'm going to use TOA. Tan equals opposite over adjacent. So my tan theta, my opposite is 12. My adjacent is 11. So I do the tan inverse of 12 over 11. This is going to give me 47 degrees. And then example 3. A 3-meter tall tree casts a shadow of 4.2 meters. Calculate the angle that the sun makes with the ground. So the sun makes with the ground is this angle here, where theta is represented. This is my adjacent side, the 4.2. This is my opposite side. That means I'm going to use TOA. Tan equals opposite over adjacent. So my tan theta is equal to 3 over 4.2. We're going to take the tan inverse of 3 over 4.2, and this gives me 36 degrees.